Good morning, student. Today we are going to discuss about the ionization potential, first ionization potential and second ionization potential. Why is the second ionization potential is greater than first ionization potential? That is the chemistry first year English medium. The minimum amount of energy is required. The minimum amount of energy is required to removal of electrons, more than one electrons, from the isolated neutral gas of an atom is called ionization potential. Remaining second one, first ionization potential. The minimum amount of energy is required to removal of only one electron from the isolated neutral gas of an atom is called first ionization potential. In previous class, we discussed about the atomic radius, variation period and group, remaining first ionization potential and ionization potential. But today we are going to discuss about the second ionization potential or second ionization potential. What is second ionization potential? The minimum amount of energy is required. The minimum amount of energy is required to removal of another electron. To removal of another electrons from the unipositive ion is called second ionization potential. Here the second ionization potential means that the minimum amount of energy is required to removal of another electrons from the isolated neutral gas of an atom. Isolated neutral gas of an atom, that is also known as a unipositive ion. Unipositive ions means that already loss of one electron, that is also known as a unipositive ion. So the minimum amount of energy is required to removal of another electrons from the unipositive ion is called second ionization potential. Second ionization potential means that here is the unipositive ion already loss of electron. So the minimum amount of energy is required. Removal of another electron from the isolated neutral gas of an atom is called second ionization potential. Here is the m+2 is the ionization potential. Second ionization potential already loss of 2 electrons. That is also called as a second ionization potential. The minimum amount of energy is required to removal of another electrons from the unipositive ion is called second ionization potential. Next, another one, very important. Why second ionization potential is more than first ionization potential? Why is second ionization potential more than first ionization potential? Or why second ionization enthalpy is more than first ionization enthalpy? It is right that IE2 is greater than IE1. Second ionization potential is greater than first ionization enthalpy. Next one, or first ionization potential. Here is the IP2. IP2 is greater than IP1. Second ionization potential is greater than first ionization potential. It says that second ionization potential is more than first ionization potential, or second ionization enthalpy is greater than first ionization enthalpy. That is the explain of IP2 is greater than IP1 or IE2 is greater than IE1. In neutral gas of an atom, the neutral atom, here is the any neutral atom. Here is also known as a neutral atom. In neutral atom, protons equal to the electrons number. In any neutral atom, here is also known as a M, also known as a neutral atom. Here is the IP gives rise to M plus or electrons minus. M also known as a neutral atom. Here is also known as a unipositive ion. M also known as a neutral atom. In neutral atom, protons equal to the electrons number. Protons equal to the electrons number. Because of this atom does not exist in the positive ion or negative ion, loss of electron or gain of electron. So here is the only neutral atom. In neutral atom, protons number is equal to the electrons number. In any neutral atom, proton number equal to the electrons number. But in unipositive ion, positive ion, protons are is greater than protons is greater than electrons number. In neutral atom, protons equal to the electrons number, but unipositive ion loss of already one electron. Protons is greater than electrons. Then in unipositive ion, the protons are is greater than electrons number. As a result, the nuclear attraction forces is strongly attracted to the outermost cell because of already loss of electrons. That is also known as a unipositive ion. The nuclear attraction forces is strongly attraction to the outermost cell, hence it requires to more energy to removal of electrons. So second ionization potential is greater than first ionization potential. Second ionization potential is greater than first ionization potential. IP2 is greater than IP1. Why? Or why ionization potential is greater than first ionization potential? In any neutral atom, protons number equal to the electrons number. But in unipositive ion, protons is greater than electrons number. So the nuclear attraction forces strongly attraction to the outermost cell. It requires to more energy to removal of electrons. So second ionization potential is greater than first ionization potential. That is the IP2 is greater than IP1 or IE2 is greater than IE1. Example, first ionization potential is less than second ionization potential. Second ionization potential is less than third ionization potential dash dash. That is the IP2 is greater than IP1. In any neutral atom, protons equal to the electrons number. But in unipositive ion, protons is greater than the electrons number. Hence, the nuclear attraction forces is strongly attraction to the outermost cell. So it requires to more energy to removal of electrons. So second ionization potential is greater than first ionization potential. That is the IP2 is greater than IP1. Next, another one, influencing factors of IP values. What is the influencing factors of IP values? The IP values, the influencing factors, IP values, ionization potential values depends on the factors. The ionization potentials depending on the factors. Those factors of first one atomic radius. Second one nuclear charge. Second one is the nuclear charge. Next one, third one screening effect. Next one, fourth one, penetration power of orbital. Next one, fifth one is the electron configuration. That is the factors. IP values depending upon the factors. Ionization potential values depending on the factors. Those factors of first one, atomic radius. Second one, nuclear charge. Second one is the nuclear charge. Third one is the screening effect. And fourth one, penetration power of orbital. Next one, fifth one is the electron configuration. That is the first one, atomic radius. Already says that atomic radius we discussed in the previous class. Distance between the center of nucleus to the outermost electron and atom is called atomic radius. Here is the, in any atom, existed center of nucleus. The distance between the center of nucleus, here is the proton nucleus to the outermost electron, that is also called as a radius. If any atom, atomic radius increases. If any atom, atomic radius increases, but nuclear charge decreases to the outermost cell. But nuclear attraction forces weakly attracted to the outermost cell. Atomic radius, if any atom, atomic radius also increases. Top to bottom, atomic radius increases. Then the nuclear attraction forces is weakly attracted to the outermost cell. If requires to less energy, to removal of electrons, so atomic radius increases, then IP values decreases. Atomic radius increases, then IP values, ionization potential value decreases. So atomic radius is inversely proportional to 1 by ionization potential value. Here is the ionization potential values also increases, then IP values decreases. but IP values also increases, then atomic radius decreases. If an atom atomic radius increases, the nuclear attraction forces decreases to the outermost shell. It requires to less energy to removal of electrons. So atomic radius values increases, then ionization potential value decreases. So atomic radius is inversely proportional to ionization potential. Second condition, if any atom, here is the atomic radius increases, but if any atomic radius, here is the atomic radius decreases, then nuclear attraction forces is strongly attracted to the outermost shell. Atomic radius also increases, nuclear attraction forces is weakly attracted to the outermost shell. But atomic radius decreases, then the nuclear attraction forces is strongly attracted to the outermost shell. Then it requires to more energy to removal of electrons. Then atomic radius decreases, then IP values increases. That is the factor of the atomic radius. Next one, second one is the nuclear charge. Second one is the nuclear charge. What is the nuclear charge? Here is the nuclear charge exists the positive charge. The nuclear charges increases to the outermost shell. It requires to more energy to removal of electrons. So nuclear charge increases, then IP values increases. If any atom center of the nucleus, then the center of nuclear, that is also known as a nuclear charge. Nuclear charge increases to the outermost shell. Hence it requires to more energy to removal of electrons. So IP values also increases. Nuclear charge also increases, then IP values also increases. So it is right that nuclear charge is directly proportional to IP values. Here is the nuclear charge increases, then IP values also increases. Due to the presence of nuclear charge increases to the outermost shell. Then nuclear attraction forces is strongly attracted to the outermost shell. It requires to more energy to removal of electrons. So nuclear charge also increases, then IP values also increases. So it is right that nuclear charge is directly proportional to IP values. That is the nuclear charge. Nuclear charge is increases to the outermost shell, or nuclear attraction forces is strongly attracted to the outermost shell. It requires to more energy to removal of electrons. So nuclear charge also increases, then IP values also increases. So it is right that nuclear charge is directly proportional to the ionization potential values. That is the second factor of the nuclear charge. Second factor of the IP values. Third one, screening effect. What is the screening effect? In multi-electron an atom, here is the inner electrons. In multi-electron atom, here is the multi-electron an atom. The inner electrons, here is the inner electrons are protected from the outermost electrons of the center of the nucleus. It's called screening effect. In any multi-electron atom, in multi-electron atom, the inner electrons are protected from the outermost electrons. Here is the multi-electron atom. The inner electrons are protected from the outermost electrons of the center of the nucleus. It's called screening effect. In multi-electron atom, the inner electrons are protected from the outermost electrons of the center of the nucleus. It's called screening effect. Screening effect is inversely proportional to 1 by IP values. Here is the screening effect is increases, then IP values also decreases. Then IP values also increases, screening effect is decreases. In multi-electron atom, the inner electrons are protected from the outermost electrons of the center of the nucleus. Is called screening effect. Screening effect is inversely proportional to the ionization potential values. Screening effect values also increases, then ionization potential values also decreases. That is the third factor of screening effect. Next one, fourth one, penetration power of orbital. Penetration power of orbital. The penetration power of orbital depends on the shape of the orbital or structure of the orbital. The penetration power of orbitals depending upon the only shape of the orbital, that is also known as a penetration power of orbital. The penetration power of orbitals depends on the shape of orbital. Depends on the shape of orbital. Then given different the penetration power of orbital order is S orbital is greater than p orbital, p orbital is greater than d orbital, d orbital is greater than f orbital. Then is the different penetration power of orbital. Then penetration power is increases, then IP values also increases. The penetration power only depending upon the shape of orbital or structure of orbital. That is the given the different penetration power of orbital is order. S orbital is greater than p orbital is greater than d orbital is greater than f orbital. In any condition, the penetration power also increases, then ionization potential values also increases. Next, another one. Fifth one is the electron configuration. Electron configuration. Here is the electron configuration. Any electron configuration. Here is the any atom. In any atom. In any atom. Here is the any, for example, here is the atom or any atom having a half filled or full filled. Electron configuration is more stable. For example, factor of the fifth factor is the electron configuration. If any atom having the half filled, for example, here is the half filled. That is also known as half filled. Next one, full filled or full filled. Completely filled with the electrons. If any atom having the half filled or full filled with the electrons configuration is more stable. More stable. Nitrogen is more stable than the oxygen because of nitrogen is half filled with the electrons, but oxygen having the full filled with the electrons. For example, here is the nitrogen atomic number 7. Nitrogen exists the half filled with the electrons. Here is the oxygen atomic number 8. Here is the 1s2, 2s2, next one 2p3. But here is the 1s2, 2s2 and 2p4. So here is the, if any atom having the half filled or full filled with the electrons are more stable electron configuration. Example, nitrogen is more stable than the oxygen. Here is the nitrogen is more stable than the oxygen because of nitrogen atom is half filled with the electrons. So is the more stable than oxygen. That is the electron configuration. That is the factor influencing of the IP values. In IP values, depending upon the factors, ionization potential values depending upon the factors. That is the first one, atomic radius, and second one, nuclear charge, third one, screening effect, and fourth one, penetration power of orbital, and fifth one is the electron configuration. That is the ionization potential values. Annual ionization potential is more important in 8 marks question in second lesson. What is ionization potential? Write the IP2 is greater than IP1 or IE2 is greater than IE1. Influencing factors of IP values. That is the 8 marks question. So first of all we write the what is the meaning of ionization potential. The minimum amount of energy is required to removal of electrons, more than one electrons from the isolated neutral gas of an atom is called ionization potential. Then first ionization potential and second ionization potential. IP2 is greater than IP1 siding. In any neutral atom, protons is equal to the electrons number. But unipositive ion, protons is greater than electrons number. So nuclear attraction forces is strongly attracted to the outermost shell. It requires to more energy to removal of electrons. So second ionization potential is more than first ionization potential. Next one, influencing factors of IP values. Atomic radius, nuclear charge, screening effect, penetration power of orbital. Next one is the electrons configuration. That is the explaining of the factor influencing of the ionization potential values.